Many features are marked on a map. If these features were written in text, the map would become too cluttered and too difficult to understand. So maps use symbols to label these real-life features. The symbols can be small pictures, letters, lines, or coloured areas to show features such as campsites, golf courses, or bus stations. The symbols may even show you things you never knew were there. Each map has a key or legend that shows the symbols and explains their meanings. A good way to learn map symbols is to use flashcards. Flashcards can be two sets of cards, one set showing the symbols and the other set giving the descriptions. By matching the two sets together, you can easily learn the different symbols that are found on an OS map. Here's a short quiz on map symbols. Can you identify the following symbols using this map? The 4 points of a compass are north, east, south and west. These points run clockwise around the compass and are known as the cardinal points. A compass always points to the magnetic North Pole, wherever you are in the world. The following two simple phrases can help you remember the order of north, east, south and west. And they are: naughty elephant squirt water, or never eat shredded wheat. These 4 points can also be described in degrees of a circle, north being at 0 degrees or 360 degrees, east being 90 degrees, south 180 degrees and west 270 degrees. By drawing a diagonal line between each of the cardinal points, you can create an 8-point compass which shows the additional directions for the northeast, southeast, southwest and northwest. When using a compass to find north, there are 3 definitions we can use. Firstly, the magnetic north. This is the direction in which any magnetic compass will point. Magnetic north is not actually at the North Pole. It is located almost 800 kilometers south of the North Pole in northern Canada. Secondly, grid north. This is the direction of a vertical, the north-south grid, lines on an Ordnance Survey map. And thirdly, true north, the direction to the Earth's geographical North Pole. Magnetic north is not a fixed point. Each year it moves ever so slightly, and you may need to check your map to see what the difference is between the magnetic north and the grid north. Although for most map skills activities in the classroom this won't make a significant difference. But the difference between magnetic north and grid north is shown on the legend of an Ordnance Survey map. To help orientate yourself when using an Ordnance Survey map, it is worth noting that the map is always printed with north at the top. This is common for most other types of maps, but not all. Now you're going to use a compass and a map together to answer the following 3 questions about direction. Take a look at this map. Using the 8-point compass, what is the direction of travel if you want to travel from Wester Deans to Spylaw? Your second question is, which direction would you travel in to go from Madrissa to Western Deans? And finally, which direction would you travel in to go from Wester Deans to Ruddenlees? If you look closely at an Ordnance Survey map, you will notice a series of grid squares denoted by a blue line. These squares are known as a grid and help you find your exact location on a map through the use of grid references. The OS National Grid System enables you to accurately pinpoint any location in Great Britain. The largest squares are 100 kilometres across, and each one is labelled with 2 letters. These letters are the unique identifiers for areas in Great Britain. On Ordnance Survey maps, further grid squares are divided into smaller squares measuring 1 kilometre across. The numbers around the edge of the maps are called eastings and northings. The eastings run from west to east, and the northings from south to north. To pinpoint a place, you take the easting number first and then the northing. An easy way to remember this is to work along the corridor and then go up the stairs in terms of which you take first and then second. To get the 4-figure grid reference for a particular place, we need to identify the 2-letter code and the 2 figures for the eastings and the 2 figures for the northings. These 2 figures together will define the grid square. So now let's look at this map. To give the 4-figure grid reference for the telephone in Seckington, first we need the 2-letter code for the Ordnance Survey map, SK, and then take the eastings 26 and the northings 07. So the final grid reference is 2607. More accurately, we could say SK 2607, but in normal use 2607 is more than sufficient for your use of 4-figure grid references. With a 6-figure grid reference, you can be even more accurate when pinpointing a place. Now imagine that each grid square is divided up into 100 tiny squares with 10 squares along each side. Using the along the corridor and up the stairs method, you can now add 2 figures to the grid reference. So the 6-figure grid reference for the telephone in Seckington is SK 261074. It wouldn't be possible for maps to show things the actual size they are in real life, so maps make things smaller using a scale. Drawing something to scale means showing it at a different size to what you would actually see if you saw the features for real. When maps are drawn to scale, things are made many times smaller than they really are. Every map has its scale printed on the front. It's usually written like this: 1 to 25,000. This means that for every 1 unit of measurement on the map, such as a centimetre, this is the same as 25,000 of those units, in this case 25,000 centimetres or 250 metres, in real life. Map scales are typically described as large scale or small scale. A large scale map will show individual buildings in detail, and they will cover a small area of land. A small scale map covers a much larger area, but it doesn't show the same amount of detail as you'd find on a large scale map. It might help you to remember that the larger the number in the scale, the smaller the scale of the map will be. Maps are drawn to many different types of scales depending on what people want to use them for. And here is just a typical range of the sorts of scales and how they might be used. A 1 to 1250 map is ideal for architects and the buildings they design and build. A 1 to 110,000 map is ideal for town planners. A 1 to 25,000 map is ideal for outdoor activities and is a typical Ordnance Survey map. A 1 to 50,000 is ideal for planning a day out. A 1 to 250,000 map is really useful for motorists and those planning longer journeys, and a 1 to 1,000,000 scale map is the sort of map you might want to use to see a whole country at a glance rather than its detail. A map shows us how the land looks as a flat 2D image. So how do we depict hills and other areas of relief on a map? Contour lines are a map's way of showing how high the land is. These are lines that join together points of equal height and they never cross. When contour lines appear closely together, this means the land slopes sharply and will be steep to climb. The further apart the contour lines are, the flatter the landscape and the more gentle the slopes. The steep hillside shown here is also higher than the more gentle slope. For example, the steeper hillside reaches a height of 100 metres, its highest contour line, compared to a height of only 30 metres on the more gentle relief. The number shown on the contour line tells you the height in metres above sea level. On a 1 to 25,000 scale map, the intervals are usually 5 metres. In mountainous areas they may be 10 metres. If you look at a map and the contour lines, you can get an idea in your mind of what the land actually looks like. William Naismith, a Scottish mountaineer, created a simple rule when walking across steep landscapes, particularly where the contour lines are very close together. Naismith's rule says you must allow an extra minute of walking for every 10 metres of height you climb.